Welcome to tonight's video on topic 2, quadratic functions. So, a couple forms for quadratic functions. The first form is vertex form. So if you have this equation, negative x minus 3 squared plus 4, we know the base equation is y equals x squared. The shape of the graph is a parabola. The a term is negative 1, which reflects the graph across the x-axis, as we remember from our transformations. Does the graph open up or down? Well, since it reflects, it's going to go down. The h is equal to 3, which moves the graph right, and k is 4, which moves the graph up, and the vertex would be at 3, 4. The x-intercepts here, if we set the f of x equal to 0, so first you move the 4 over, then you divide by negative 1, so you get 4 equals x minus 3 squared. Then you take the square root of both sides, putting the plus or minus on the left. So you get, I'm just going to switch sides to the equal, so it's x minus 3 equals plus or minus 2. So you add the 3 to both sides, so you get x equals 3 plus or minus 2. So that means x equals 3 plus 2, or 3 minus 2, which means it's 5 or 1. So the two x-intercepts are 5, 0, and 1, 0. The y-intercept, you put 0 in for x. So it becomes the opposite of negative 3 squared plus 4. It becomes the opposite of 9 plus 4, which is negative 5. So the y-intercept is 0, negative 5. When you sketch this, the vertex is 3, 4. The y-intercepts are 5, or sorry, the x-intercepts are 5, 0, and 1, 0. And the y-intercept is 0, negative 5. So now you sketch the parabola. Now it says, is there a maximum or minimum value? Here, there's a maximum value. The maximum value is is 4. It's the y coordinate of the vertex, and it occurs at x equals 3. The equation for the axis of symmetry, well, if you draw a line down the center of the vertex, a vertical line, it divides it into 2 equal parts. So the axis of symmetry is x equals 3. And notice that could give you a point, like for example, see how it's 0, negative 5 here is 3 units away from that line. So if you go 3 units on the other side, you get the corresponding point of 6, negative 5. The domain is always all real numbers for any quadratic. The range, well, since the maximum value is 4, it's got to be everything less than 4. So that leads us to the vertex form. The vertex is whatever the h, is whatever the h comma k is. The axis of symmetry is x equals h. It opens up if a is greater than 0, which means there is a minimum. and it opens down if a is less than 0, which means there's a maximum. Find the x-intercepts by plugging in 0 for f of x, and y-intercepts by plugging in 0 for x. So another example here, x minus 2 squared plus 1. So the vertex we know, because the h is 2 and the k is 1. So we know it's 2, 1. It opens up because a is positive. So the x-intercepts, when we set g of x equal to 0, we get x minus 2 squared plus 1. So we move the 1 over. And we take the square root, leaving plus or minus. So it's plus or minus I equals x minus 2. I don't know why I keep writing an x. So then you add 2, so you get 2 plus or minus I equals x. So we know, since the x-intercepts are imaginary, that there are no x-intercepts. It doesn't cross the x-axis. The y-intercept, when you put 0 in for x, you get 0 minus 2 squared plus 1. It would be 4 plus 1, which is 5. So the y-intercept is 0, 5. So notice you have the vertex at 2, 1, the y-intercept at 0, 5, the axis of symmetry we know is x equals 2. All right. And then that means we can go symmetric here. So since this is 2 units away, we can also go 2 units this way to get the point 45 on the graph. And that means that your parabola looks like that. There is a minimum value of 1, that's the y-coordinate of the vertex, at x equals 2. The domain, remember it's all real numbers. And the range, well, since that's a minimum value, the smallest it can be is 1, and it's going to be everything bigger than 1. Now, the next one. So here, the vertex is equal to 1, 8, since h is 1 and k is 8. Now, it opens downward since a is negative. Now, as far as the x-intercepts go, so we subtract 8, divide by negative 2, and then take the square root. So you get that 2 is equal to, plus or minus 2 is equal to x minus 1. So 1 plus or minus 2 equals x. So it's either 3 or negative 1. So the x-intercepts are 3, 0, and negative 1, 0. The y-intercept, when you put in 0 for x, you get negative 2 times negative 1 squared. So negative 1 squared is 1. So it's going to be negative 2 plus 8, which is positive 6. So now sketching this at 1, 8, which is up here, Okay, I go up one more, sorry. And then the y-intercept is 0, 6. That means that the axis of symmetry is x equals 1. And then the other, since this is 1 unit to the left, 1 unit to the right is 2, 6. Then the intercepts of -1, 0 and 3, 0. And then notice your graph goes like that. All right, so then the maximum value here is 8. And it occurs at x equals 1. The domain is all real numbers. The range is less than or equal to 8, because 8 is the maximum. All right, so that's if it's in vertex form. But now, standard form is when it's written as a quadratic f of x equals ax squared plus bx plus c. That is quadratic. This is a parabola. This function opens up because the a is positive. So if we use the quadratic formula, remember a quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we get that b is 4, so negative 4 plus or minus the square root of 4 squared minus 4ac all over 2a, which is 1. So if you get negative 4 plus or minus the square root of 16 plus 20 all over 2, because negative 4, negative 5 is positive 20. So x equals negative 4 plus or minus the square root of 36 over 2. X equals negative 4 plus or minus 6 over 2. So it gives you negative 4 plus 6 over 2 and negative 4 minus 6 over 2. So it gives you 1 and negative 5. All right, so if we plot the intercepts, it's at 1, 0 and negative 5, 0. So draw the axis of symmetry. Well, remember the axis of symmetry has to be between these two in the middle. So if you count 1, 2, 3, 1, 2, 3. So the middle here would be at 2. So the axis of symmetry has to be at x equals 2. How does that relate to the quadratic formula? Well, notice, or sorry, negative 2. It's not positive 2, it's negative 2. How does that relate to the quadratic formula? Well, notice that negative 4 over 2, right? Negative 4 over 2 is negative 2. So basically, in the quadratic formula, the vertex is the negative b over 2a part. So that is your axis of symmetry. So that means the vertex of the function also has to be at negative 2. Right? So the x-coordinate of the vertex is negative 2. So now to find the y-coordinate of the vertex, you can plug in that negative 2 into the function. gives you 4 minus 8 minus 5, which gives you negative 9. So the vertex is negative 2, negative 9. So it is down here. 1, 2, 3, 6, 7, 9. So negative 2, negative 9. That's the vertex. Now it says find the y-intercept. Well, we set x squared plus 4x minus 5 equal to 0. Right? Actually, sorry. We put in 0 for x, so we want to find f of 0. So 0 squared plus 4 times 0 minus 5. So we get negative 5. And then that means that you can also go 2 spaces to the right at 4, negative 5. And then you graph your parabola. All right. So that means that the vertex here is equal to the x equals negative b over 2a. The axis of symmetry, well, sorry, the vertex is negative b over 2a, and then f of negative b over 2a, meaning when you put negative b over 2a back in. So that's how you get the x and the y. The axis of symmetry is x equals negative b over 2a. It opens up if a is greater than 0, which means there is a minimum. Opens down if a is less than 0, which means there's a max. Find the x-intercepts by plugging in 0 for f of x, and the y-intercepts by plugging in 0 for x. So some of that stuff didn't change with vertex and standard form, but some of it did. So now, given the vertex, given this equation, find the vertex. So to find the vertex, so negative b over 2a, negative 4 over 2 times negative 1, that gives us negative 4 over negative 2, which is positive 2. So the x-coordinate of the vertex is 2. Now to find the y-coordinate, we put that 2 back in the function. And we get 5. So the vertex is 2, 5. The x-intercept, right? So we put 0 in for g of x. So we can do the quadratic formula. For b squared is 16 minus 4ac all over 2a. So basically it's negative 4 plus or minus the square root of 20 all over negative 2, which means it's negative 4 plus or minus 2 rad 5 over negative 2, which means when you divide, you get 2 plus or minus rad 5. So those are the x-intercepts. They are at 2 plus rad 5 comma 0 and 2 minus rad 5 comma 0. The y-intercept, you put 0 in for x. And you get 1. So the y-intercept is 0, 1. So 0, 1 is here. Then you graph the corresponding point. to get 4, 1. And this graph, sorry, is going to open down because A is negative. And then for the x-intercepts, the square root of 5 is like a little more than 2. So if we go to the 2 minus like 2.1, so that's going to be about here. For 2 minus the square root of 5, 0. You can also type it in your calculator and get what it would be. And then if you add like 2.1, you get a little more than 4 right here. And then you're going to graph it. And remember to put the axis of symmetry right there. So the axis of symmetry is x equals 2. And then there is a maximum value of 5 at x equals 2. The domain, remember, is all real numbers. And the range is from -infinity to 5 inclusive. All right, so a couple things here. We can, without graphing, we can determine whether the function has a maximum or minimum value, because if it goes downward, it has a maximum, and this one, because A is negative, will go down, so therefore there's a maximum value. Now, to find the maximum value, we have to find the vertex. Well, we know to find x, it's -b over 2a, which is 1. And to find y, we put that 1 back in. So we get -3 plus 6 minus 13, which is -10. So we have a maximum value of -10 occurring, or the maximum value of -10 occurs at x equals 1. So that is there. The domain, remember, is all real numbers. And the range, since it is a maximum value, it's going to go -infinity to -10 included. Now this question here, the next one, so the archer's arrow follows a parabolic path, right? So it might help to draw this. The height of the arrow in feet can be modeled by the equation -0.005 x squared plus 2x plus 5, where x is the horizontal distance in feet. So basically, you have an archer. Here's the, h of x, and then here's x. And the archer shoots up the arrow, and then eventually it's going to come and hit the ground, right? So, what is the maximum height of the arrow? This is basically telling you find the vertex. So to find the vertex, you go x equals -b over 2a. And when you put that in your calculator, you get 200. To find the y-coordinate of the vertex, you put that 200 into the function. And then you basically, when you type it in your calculator, you'll get 205. So that means the maximum height of the arrow is 205 feet, which occurs 200 feet from its release. Because remember, the y is the height, and the x is the horizontal distance. So this is 200, and this is 205. So this is the point 200, 205. That is the maximum height of the arrow. The horizontal distance the arrow travels before it hits the ground. Well, here's the ground. So basically, when you do this, you're finding the x-intercept, right? So this is the x-intercept, which means you have to set h of x equal to 0. So when you do this, you're going to do the quadratic formula. Four times a, which is negative 0.005 times c, all over 2a. Now type this in your calculator. You might have to type one time for positive and one time for negative, and you get like negative, I want to say you get negative 4 point something, or you get 402. So remember, distance can't be negative, so it will be 402. So basically, the arrow travels 402 feet before it hits the ground. All right, the next question says, among all so if x is the smaller of the two numbers, then y minus x equals 8. So then y is going to equal x plus 8. So x plus 8 is equal to the bigger number. So the product that must be minimized is that x times x plus 8. Right? So basically, if you multiply this out, it's x squared plus 8x. So will it have a maximum or minimum value? It has a minimum value, right? Because it opens up. And then when you find the vertex, to find the minimum value, remember x equals negative b over 2a. So it's equal to negative 4. So x is the smaller number. So then the bigger number, negative 4 plus 8, is equal to positive 4. So the two numbers (4) and negative 4 have a difference of 8 and are the minimum product. So basically those two numbers give you the minimum product for all numbers whose difference is 8. All right, last one. This one here, it says you have 120 feet of fencing enclosed in a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. So remember that what must be maximized is the area, right? So remember we did this previously where we had a picture and we said it's x right? And then to find the other side, we made this y, and we know the perimeter is 120. So we know 2x plus 2y equals 120. So 2y equals 120 minus 2x. So y, when you divide, is 60 minus x. So let x equal the width, and then 60 minus x is going to equal the length. So the function is going to be a of x equals x times 60 minus x, which equals negative x squared plus 60x. It's going to have a maximum value, right? It's going to have a maximum value because the negative means it goes down. And so when you find the maximum value, remember that it's going to be negative 60 divided by 2, which is negative 30. And then so you have to put in, because it says what is the maximum area, so we have to put in the negative 30. So the dimensions, it would be, 2 times negative 1, so it would be a positive 30. My fault. So the width would be 30. That means the length would be 60 minus 30, which is also 30. And then the area, the maximum area, you could put in, because it's negative 30 squared plus 60 times 30. You could also just multiply 30 times 30. Either way, you're going to get 900 square feet as the maximum area. And you'd write that as a sentence. All right, I hope you enjoyed the video. I will hope to see you all in class. And if you have any questions, please feel free to ask.